Scientists may have found the answer to a huge mystery about the early universe thanks to JWST. The answer to this mystery lies in this photo, which focuses on a specific type of light emitted by hydrogen called Lyman-α. Scientists think Lyman-α was abundant in the early universe, produced by vigorous star and galaxy formation, but we shouldn't actually be able to detect it. That's because there was a lot of dense neutral hydrogen surrounding these early galaxies, which should have absorbed and scattered this kind of light. But we have been able to detect this Lyman-α emission. Now we know why, thanks to JWST's NIRCam or near-infrared camera. The answer is galaxies, and the research was published in Nature Astronomy. Here is what is going on. Remember that looking deep into the universe is also like looking back in time because of how long the light takes to reach us. When we're peering into the darkest depths of the universe, thanks to JWST's infrared optimization, we're also looking back in time to the early universe. We're focusing here on what's called the epoch of reionization. We don't know exactly when this era started, but scientists think it ended around 12.8 billion years ago. That would be a billion years after the Big Bang. Before this period started, the universe was in what we call the dark ages, meaning it was literally dark. Dense neutral hydrogen gas distributed throughout the early universe meant that the universe was opaque. Basically, you couldn't see through it. Think of straining to see the stars in the sky on a cloudy night. This is what the early universe looked like. Reionization is basically when the universe became see-through. This occurred when the neutral hydrogen became dense enough in areas to collapse into the first stars and galaxies. This is part of the process that scientists think ionized the universe, though it's still unclear on exactly how that happened and what contributed to the process. Once the epoch of reionization was complete, the universe looked much like it does today, with light able to freely travel through it. This is all part of why it is so challenging to see light from the early universe and why an infrared optimized telescope is so important to detecting the earliest stars and galaxies. During the era of reionization, visible and UV light didn't always travel freely through the universe, but infrared light still did. Okay, so now let's get back to that central issue, Lyman-α light. Before the epoch of reionization ended, that neutral hydrogen surrounding these early stars and galaxies should have blocked Lyman-α light, but it hasn't, and now scientists know that galaxies are responsible. Previously, scientists were able to detect the largest and brightest galaxies from this time thanks to observatories like Hubble and Spitzer. This is where they detected Lyman-α emission, but now thanks to both the angular resolution and sensitivity of JWST, we found that these large galaxies are not in fact surrounded just by dense neutral hydrogen. JWST was actually able to detect smaller, fainter galaxies surrounding the larger ones, while Hubble was only able to detect the single large galaxies. You can see that here in this image. This is the galaxy EGSY 8P7 as taken by Hubble. This is how it looked when the universe was approximately 600 million years old. Now here's the JWST photo again. You can see the central galaxy here along with two very close companion galaxies. This image was captured with 7 different near-infrared filters. The galaxies are interacting and merging with one another, and star formation is happening here at a frenetic pace. This star formation and galaxy interaction and mergers is what was able to clear hydrogen and allow the abundant Lyman-α emissions to escape.